Hi guys, welcome back to our channel Unknown IITians. Today we are going to discuss the topic straight lines. Today we are going to cover rectangular coordinate system, distance formula, section formula, area of triangle, slope of a line, relation of angles between two lines and their slopes, equation of line, distance of a point from a line, distance between two parallel lines and sum squared error. So let's get started. Firstly, what is rectangular coordinate system? Here we are given two lines plotted in a graph. This is termed as x axis and this is termed as y axis. The point of intersection of these two axes is known as origin. This point is origin 0, 0. So any point in 2D plane can be represented in this rectangular coordinate system. Okay, so this is termed as first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So in first quadrant, x value and y value both are positives. In second quadrant, x value is negative and y value is positive. In third quadrant, both x and y are negative. In fourth quadrant, x is positive, y is negative. So a point in a 2D plane is represented as x, comma, y. The number or the point here represented here is taken as the point on x-axis, and this is taken to be the point on y-axis. Next, distance of a point from origin. So for suppose we are given a point in 2D plane. Here let's take this example only, 3, 4. So now what is the distance of this point from the origin? As we have discussed before, origin is the point of intersection of x-axis and y-axis. So from this intersection point, what is the distance of a given point? As we have discussed before, a point in a 2D plane can be represented in xy format. So this is, here we are given 3, 4. So the distance from origin to the given point is root over x square plus y square. That means root over 3 square plus 4 square. That is root 25, that is 5. So distance of this point from origin is 25 units. Okay, sorry, 5 units, not 25 units. So basically the formula for a distance of a point from origin is root over x square plus y square, where x is the coordinate of x-axis, coordinate of x-axis, y is coordinate of y-axis. Okay, next. Now what if we are asked distance between two points? Okay, distance between 2 points. So for suppose we are given a point A which is x1, y1, and a point B which is x2, y2. So these are 2 points in the 2D plane. So we were supposed to find the distance between these 2 points. So as here these 2 points are represented in the 2D plane rectangular coordinate system, this is called as. So point y1 and point y2, x1 and x2. Okay, so this is first point A, and this is point B. So now we were supposed to find this distance. Okay, so now let's see what is this distance. This is x2 minus x1, and this distance is y2 minus y1. So how did we measure this? So basically this is origin. So the distance of x2 from origin, this point x2 is x2, and distance of this point x1 from origin is x1. So let's draw a diagram. This is x2 and this is x1. Let's erase this. This is x1. So now distance between these 2 points is x2 minus x1. Similarly for y2 and y1. So now the distance is, using the Pythagoras theorem, this is the right angle this forms a right angle triangle. So now we have to find the length of the hypotenuse. So we are given the 2 perpendicular sides. So from Pythagoras theorem, d is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula for distance between 2 points in a 2D plane when the coordinates of the points were given. Okay. So now let's discuss section formula. What is section formula? For suppose we are given a line, 2 points on line are x1 comma y1 and x2 comma y2. So now we have to find a point C in between the points A comma B, which divides the line joining both the points A comma B in the ratio m:n. So the point which divides the line joining A and B coordinates in the ratio m:n. So to find the coordinates of this particular point C, we use the section formula. So the point C x comma y is mx2 plus nx1 by m plus n. Y coordinate is m by 2 plus n, y1 by m plus n. So be careful here. We are multiplying m with x2 and with x1. Not m1 x1, it's mx2. Okay. So this is for internal division. What is internal division? Here the point C is in between the points A and B. So here the point is dividing the line joining these 2 points internally. Okay. Now what if the division is external? That means the point C is not in between A and B. Here this is point A, x1 comma y1. This is point B, x2 comma y2, and this is some point C. So now what if we are supposed to find the coordinates of this point which divides the line joining the points A and B in the ratio m:n externally. Be careful here, this is external division. The formula is similar to the first one, but the plus is replaced with minus. That means mx2 minus nx1 by m minus n comma m y2 minus n y1 by m minus n. Be careful, when it is given as internal division, we write plus in place of minus, and also here we are multiplying x2 with n. Okay, this section formulas are very important. Many questions will be asked. Next, midpoint formula. This is also an application of the section formula. So basically, when we are given a line and given 2 points, then we are supposed to find the midpoint of this line. That means the point must be equidistant from both the points A and B. This is length L and this is also of length L. That means the ratio in which this point divides the line is 1:1. Okay, so that means substituting 1 and 1 in the section formula will give you x1 plus x2 by 2 plus y1 plus y2 by 2. This is the formula to find midpoint of a line when 2 points are given. Okay, 2 points on the line are given. Okay, next, area of triangle. So for suppose, let's take a coordinate plane. Here we are given 3 points. These 3 points together forms a triangle. Okay, now suppose we were asked to find area of this triangle. Okay, then the formula is half into the determinant of the matrix containing the coordinates of this given 3 points. Okay, that is half into x1 y1 1, x2 y2 1, x3 y3 and 1. Okay, so here this row will always remain, it's not a row, it's column. This column will always remain as 1, 1 and 1. These 2 columns represents, one column represent the x coordinates of the given 3 points and other column represent the y coordinates of the 3 given points. So after finding the determinant, this is the form of the triangle: x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now let's look at an example. We are given a triangle of coordinates minus 2, 1, 3, 2 and 1, 5. So as we have seen before, what is the formula for area of the triangle? Half into mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, now substitute. So let's consider this is x1, this is x2, this is y2, x3, this is x1, this is y1, x2, y2, x3 and y3. Okay, now substituting these points in the formula gives us half into x1 is minus 2, y2 is 2 minus y3 is 5 plus 3 into 5 minus 1 plus x3, 1 into 1 minus 2. Okay, this is minus 2 into minus 3 plus 3 into 4 plus 1 into minus 1. That will give you half into 1 by 2 into 6 plus 12 minus, I'm sorry, did I make a mistake here? No, it's correct. Half into 1 minus 2. Yeah, this is minus 1. So this will give you the area of given triangle. Okay, next, here we have an important point to discuss and as well as to remember: collinear points. What are collinear points? For example, we were given 3 points A, B and C. Then have we determined whether these particular points are collinear or not? So basically, what are collinear points? The points which lie on the same line. The points which lie on the same line are called collinear points. So if we were supposed to check whether the given points are collinear or not, we simply find out the area formed by these 3 points, area of the triangle formed by these 3 points. If that area is evaluated to be 0, when we calculated the area, if that evaluates to be 0, then those 3 points are collinear. Okay, we have to find the area of triangle. If that is 0, then the points are collinear, else the points are non-collinear. Okay, next, slope of a line. We were given a line. Okay, this is a point x1 comma y1, and this is a point x2 comma y2. That means this is x1, this is x2. Let's use a different color. y1, this is y2, okay. Now this distance is x2 minus x1, and this distance is y2 minus y1. So as these two are equal distances, this distance is x2 minus x1. Similarly, this is y2 minus y1. Okay, so now this is theta. What is theta? Theta is the angle made by the line with x-axis. So as these two horizontal, the x-axis and this horizontal line are parallel, this is also theta. Okay, now for a given line which makes angle theta with the x-axis, slope of the line is given as tan theta. Slope of the line is equal to tan theta. Here m is slope of the line. Okay, from the diagram, what is tan theta? Tan theta means opposite by adjacent. Opposite side is y2 minus y1. Adjacent side length is x2 minus x1. So this is the tan theta. That means slope for a given line that is making angle theta with x-axis, and when the two coordinates of that particular line are given. Okay, next, here we have two cases: parallel lines and perpendicular lines. So firstly, what are parallel lines? Parallel lines are the lines which make same angle with x-axis. That means, for suppose, let's take, here we have two lines. This is theta 1 and this is theta 2. If theta 1 is equal to theta 2, then the lines are considered as parallel lines. So here, if theta 1 is equal to theta 2, that implies tan theta 1 is equal to tan theta 2. That means slopes of these two lines are also equal. So let m1 be the slope of line 1 and m2 be slope of line 2. If these two are equal, then they are considered as parallel lines. Now coming to perpendicular lines. So for example, here we are taking two lines. So angle between those two lines is 90. That means the difference between the angles made by the lines with x-axis is 90, equal theta 2 minus theta 1. Theta 2 is the angle made by line 2 with x-axis, and theta 1 is the angle made by line 1 with x-axis. So if this is equal to 90, then they are considered as perpendicular lines. So now let's apply tan on both sides. Now theta 2 is equal to 90 plus theta 1. Applying tan on both sides gives tan theta 2 is equal to tan of 90 plus theta 1. That gives us tan theta 2 is equal to minus cot theta 1. Taking cot on that side gives you tan theta 1. So finally, tan theta 1, that means m1, tan theta 2, that means m2. The product of these two slopes is minus 1. So what we can conclude, if the product of slopes of two lines is minus 1, then they are considered as perpendicular lines. Okay, now let's discuss relation of angles between two lines and their slopes. So for suppose we were given two lines L1 and L2, and the angle made by these two lines with x-axis are A1 and A2. So now we were supposed to find the angle between the lines L1 and L2. So these are different. This A1 and A2 are the angles made by the lines with x-axis. But now we were supposed to find the angle between these two lines. So the formula is the angle with tan inverse of m2 minus m1 by 1 plus m1 m2. This is the formula for angle between two given lines, where m1 is slope of the line, m2 is slope of line 2. So if theta is evaluated to be 0, then the lines are parallel. If theta is evaluated to be 90, then the lines are perpendicular. Okay. Next, representation of a line. So for example, let's consider the coordinate system x and the coordinate system y. Now we were given a point A, B. Okay. So now we are representing this A, B in coordinate plane like this. So how do we get this point? So this is, okay, let's use another color. Okay, so basically this is the line x is equal to a, and this is the line y is equal to b. So the point of intersection of these two lines is a comma b. So now for example we draw a line like this, something like this. So this is the line containing infinite number of points in such a manner. That means, for example, here we are having some point c comma d. That means this is the line x is equal to c, and this is the line y is equal to d. So the intersection of these two lines is the point c comma d, and this point is also passing through this particular red line. Okay, this is how we join all the points and represent the equation of line. Okay, next, here to find equation of line we have different methods. So first one is point slope line. For suppose we were given slope of the line m, and we were given a point x1 comma y1 on the line. Okay, this point is on the line, slope of the line is m. Then what is the equation of line? Y minus y1 is equal to m into x minus x1. So here the equation of the line means the locus of all points that lie on particular line. So this is the locus of all the points that lie on the particular line. So here we are given one point on the line and the slope of the line. So the equation of the line is y minus y1 equal to m into x minus x1. This is one of the important formulae in the straight lines chapter. The next one is 2-point form. That means this time we were not given the slope. We were given two different points on the line, x1 comma y1 and x2 comma y2. We have discussed previously in this lecture that slope of a line when 2 points were given is y2 minus y1 by x2 minus x1. This is the slope of the line. So here previously we discussed the slope point form. So the slope point form is y is equal to y minus y1 is equal to m into x minus x1. So here we got the m. By replacing m with this value, we get the 2-point form of a line. So here we are given equation of the line when 2 points of the line were given is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Here this is the slope of the line. Okay, this is also very important. So now let's discuss slope intercept form. Y is equal to mx plus b. Here m is the slope of the line, b is intercept. So have to find this intercept. Okay, for this is the line equation. Now let's substitute x is equal to 0. That is y is equal to B. That means the point is 0, B. So this is the y-intercept. Okay. So if we were given the slope and intercept, then simply y equal to mx plus b is the formula for equation of the line. Okay. Next, intercept form. So we were given the line like this. This is A. That means this point is 0, A comma 0. This is B. That means, wait, let me write it clearly. We were given the graph of the line. This is the line. Okay. Extending both ways. This is the y-intercept and this is the x-intercept. That means this point is B 0 comma B and this point is A comma 0. So we were given two intercepts. Then how to find the equation of the line? The formula is x by A plus y by B is equal to 1. This is the equation of the line where A and B are the two intercepts given. So we have discussed so far 3 methods. One is point slope form, two-point form, slope intercept form, and two intercept form. So these are the 4 methods to find equation of line. Okay. Next, here for suppose the line, this is the general equation of the line ax plus by plus c. This is the general representation for a straight line L. Okay. Now from this equation have to find the slope and x and y intercepts of a line. Okay, let's see how is it. How to find ax plus by plus c is equal to 0. by is equal to minus ax minus c, taking these two terms to the right side. Now dividing with b on both sides will give minus a by bx minus c by b. So now this is in the form of y is equal to mx plus b. As we have discussed previously, now comparing these two equations, m is, that means slope is minus a by b and the y-intercept is minus c by b. Okay, now how to find out the x-intercept? Simply by substituting y is equal to 0 and solving the remaining equation will give you the x-intercept. So for a given general equation of line ax plus by plus c is equal to 0, the slope of the line is minus a by b, y-intercept is minus c by b, and the x-intercept is minus c by a. Okay. Next, we discussed before the condition for parallel lines is m1 is equal to m2. Okay, Now we discussed in the general form equation of a line, the slope is minus a by b. So for line, let's consider we have two lines, a1x b1y plus c is equal to 0, and the other equation a2x plus b2y plus c is equal to 0. So the slopes are, slope for this is m1 and slope for this line is m2. So m1 is equal to minus a1 by b1, m2 is equal to minus a2 by b2. So now let's discuss both the conditions at the time. So for lines to be parallel, m1 is equal to m2. For the lines to be perpendicular, m1 m2 is equal to minus 1. So here m1 is this and m2 is this. So m1 is equal to m2, that means minus a1 by b1 is equal to minus a2 by b2. Now cancelling minuses, a1 b2 is equal to a2 b1. This is the condition for the lines to be parallel. And multiplying both a1 into a2 by b1 into b2 is equal to minus 1. Okay, so by simplifying we'll get this condition. So for the two lines given in their general forms, for those to be parallel, the condition is a1 b1 equal to a2 b2, and for those lines to be perpendicular, the condition is a1 b1 plus a2 b2 is equal to 0. So these are also very important formulas. Next, distance of a point from line. Okay, now so far we discussed distance of a point from origin and distance between two lines. So now let's see how to find out the distance of a point from a line. Okay, so here this is the line, okay, and this is the point. Let's consider it as x1 comma y1. Okay, so we have to find out this perpendicular distance d, that is considered to be the distance between the point and line. So this line equation is ax plus by plus c is equal to 0. Okay, now perpendicular distance of the point from a line is a into x1 plus b into y1 plus c divided by root over a square plus b square. Okay, here x1 and y1 are the coordinates of the given point. So we are substituting the coordinates in the given line equation. Okay, here be careful, this is x1 and y1. Okay, this will give us the perpendicular distance of a point from a line. Okay, next, distance between two parallel points, parallel lines, as we have discussed before, the parallel lines will never touch each other throughout the journey. That means though they extend from minus infinity to infinity, they will touch at no single point. Okay, So this is one of the line and this is the other line. So now these two are parallel. So the distance between these two lines will always remain the same, because the angle will always remain the same and they never meet each other. The distance between the two lines will always remain the same. So this is the perpendicular distance D. Okay, now for suppose this line equation is ax plus by plus c1 is equal to 0, and this line equation is ax plus by plus c2 is equal to 0. Here these are parallel lines, the x and y coefficients will be same, but this c1 and c2 will be changed. Okay, so now the formula for the perpendicular distance is mod of c2 minus c1 by root over a square plus b square, where is the c2 and c1 are these terms and a and b are the coefficients of x and y coordinates. Okay, here remember the distance between the two parallel lines will always remain the same till the end. There will be no change in the distance. And here for the parallel lines in the equation, the a and b values will be the same, the c values will be varying. Okay, simply, so the distance between these two parallel lines is c2 minus c1 by root over a square plus b square. Remember, here there will be mod, as the distance will never be a negative value. Okay, the quick recap. So what we have discussed so far, let's revise them once again. Okay, slope intercept form, y is equal to mx plus b. M is the slope and b is the y-intercept. Point slope form, when we were given a point on the line and slope of the line, the equation of the line will be y minus y1 is equal to m into x minus x1. And the standard form, ax plus by is equal to c. We have discussed before as ax plus by plus c is equal to 0, and both are same. Okay, a must be positive is the condition. And the intercept form, that means when we were given both x and y intercepts, that is x by a plus y by b is equal to 1. So when the line is vertical, that means it has only a as the x-intercept, but there is no y-intercept. Okay, that means the line is vertical, like just like this. This is the line. Okay, this is the line, vertical. In case of horizontal, it will have only the y-intercept but no x-intercept. That means the line looks in this way. This is the horizontal line and this is the vertical line. Okay, so now let's discuss the sum squared error, simply termed as SSE. Okay, this is also one of the important concept. You can expect a question in your examination. Okay, in your quiz 1 or in your end term, definitely you can expect one question from this sum squared error. This is very important concept. Okay, what is the error? Error means the actual value minus expected value. Okay, so for example, we expected our expected value is something around 5 and the actual value is something around 7. The error is 2. Okay, so here in this case we are considering here as a square term also. That means the error is actual minus accepted whole square. Okay, don't get confused. Here in the sum squared error theory, error is equal to actual minus expected whole square. So for example, here we are given a line equation y is equal to mx plus c. The sum squared error of this line is yi minus mxi minus c whole square, where x1, xi and yi are the points on the line. Okay. Independent variables and dependent variables. So what are dependent variables? The variables whose value is dependent on some other variables or constants is a dependent variable. What is independent variable? Independent variable will simply not depend on any other value. Okay, so here x value is independent. That means x can be anything. No condition is applied. But for y value, it is depending on the slope, it is depending on the x value, and it is depending on the intercept value. So here y is termed as a dependent variable. So the sum squared error is always calculated on the dependent variable, because for an independent variable it can be anything. Okay, there is no error, there is no actual value, there is no expected value, it can be anything. But in case of a dependent value, there comes the terms actual and expected. So this sum squared error will always be calculated for dependent variables. Okay, now let's look at an example. Okay, you have been closely monitoring your bike's mileage recently. This is the table. Okay, let's highlight some points. 2 rows representing amount of bill paid for fuel and corresponding mileage. Okay, y be the amount paid, y is the amount paid, and x is the corresponding mileage. Okay, you have noted down the distance traveled each time when fuel meter falls back to a fixed reference mark, and predicted that the equation best fits the line y is equal to 5x minus 22. What will be the SSE with respect to the best fit line? Okay, so now let's solve this question. Here we considered the line. This will best fit. The best fit line equation is y is equal to 5x minus 22. Okay. Here the x are the independent variables. So we are substituting these x values in the equation one by one. 5 minus 20, y is equal to 5 into 15 minus 22. Sorry, it's not 20, it's 22. Y is equal to 5 into 16 minus 22, and so on. We calculate all the y values for these different x values. Okay, so here for example we are getting 100 minus 22, that is 78. Here we are getting 75 minus 22, that means it is 53. Here we are getting 80 minus 22, that means it is 50. So for this corresponding x value, we were given a y value here. So for this we were given 75. For this, let's use another color. For this we were given 55, and for this we were given 60. So here there is something different. Okay, 70, 78 and 75 are not same. 53 and 55 are not same. 60 and 58 are not same. So here there is an error between the expected value and the actual value. So here we are expecting the value to be 78, but the actual value is 75. So this is termed as the error. Okay, now to find the error, we have to find all the corresponding y values. Okay, and then subtract the both y values, okay, with this y value and the corresponding y value given in the table. That means 78 minus 75 whole square. Okay, as it is square, you can write it as 75 minus 78 or 78 minus 75, both are same. So correspondingly, you have to calculate for all the y values and add their squares. Okay, all the y values, subtract them from the corresponding y values given in the actual table, and sum of their squares is the SSE of the given data. That means it is SSE with respect to best fit line. Okay, thank you so much, guys. That's all for today's video. We have discussed about straight lines, slopes, angles of the lines, area of the triangle, how to find the area of a triangle, how to determine whether the points are collinear or not, different forms of line equation, the general form, how to derive the slopes and all from the general form, and finally SSE, sum square error. Okay, so these are the topics for today. Hope you enjoyed the lecture. Thank you so much.